Weak signal strength in a wireless communication network can be caused by a variety of factors, and distance between the device and base station is one possible cause. If a device is too far away from the base station, the signal strength may weaken, making it difficult to maintain a reliable connection. In this video, I will explain to you the relationship between high-band spectrum, mid-band spectrum, base station and 5G networks, and how they affect other devices' application and 5G worlds. mmWave is a type of high-band spectrum that is being used in the latest wireless communication technologies, including 5G networks. mmWave frequencies refer to radio frequencies typically in the range of 24 to 40 GHz, but can also include frequencies up to 300 GHz, which are much higher than the frequencies used in earlier generations of wireless technology like 3G and 4G. One of the advantages of using mmWave frequencies in 5G is that they can provide very high data transfer speeds and low latency. 5G promises speeds up to 10 times faster than 4G, with theoretical peak speeds of up to 20 gigabits per second in ideal conditions. Actual speeds may vary depending on factors such as network congestion, signal strength, and distance from the transmitter. This is because mmWave frequencies have a much larger available bandwidth than lower frequency bands, which allows more data to be transmitted simultaneously and avoid network congestion. This makes mmWave ideal for applications that require high-speed data transfer, such as virtual reality, augmented reality technology, and 4K or 8K video streaming. When many devices connected to a wireless network, the available large bandwidth not easily becomes saturated, while not leading to slower speeds, weaker signal strength and latency. 5G networks have very low latency or delay, which means that devices can communicate with each other almost instantly. This is important for applications like online gaming, autonomous vehicles, and remote surgery. Example: in autonomous vehicles, 5G technology can enable vehicles to communicate with other vehicles, traffic signals, and other infrastructure in real time, allowing them to make better and safer decisions on the road and avoid collisions. As for remote surgery, 5G can be used to enable surgeons to perform operations on patients who are located in a different location. This requires a high-speed and low-latency connection to ensure that the surgeon's movements are transmitted in real time and without delay. With the high speeds and low latency of 5G networks, it may be possible to perform remote surgeries with greater precision and reliability than ever before. However, there are also some challenges associated with using mmWave frequencies in 5G networks. One of the main challenges is that mmWave signals have shorter wavelengths, which means they are more easily blocked by obstacles like buildings and trees. Buildings, trees, and other physical obstacles can block or reflect wireless signals, causing signal strength to weaken. This means that, in order to provide consistent coverage with mmWave, 5G networks may need to rely on a larger number of smaller cells and antennas placed more closely together, which can be more complex and expensive to deploy. To improve the coverage and reduce the interference, mmWave equipment often includes beamforming technology, which can focus the signal in a specific direction. Overall, mmWave is an important part of 5G technology, but it is just one of several frequency bands that can be used to provide 5G coverage and capacity. In addition to mmWave, 5G can also operate in other frequency bands such as mid-band spectrum, which may be better suited for providing coverage over larger areas or penetrating buildings and other obstacles. Centimeter wave is typically categorized as a type of mid-band spectrum. Centimeter wave is a type of high-frequency radio wave that falls in the frequency range of 3 to 30 GHz, which is slightly lower than millimeter wave frequencies. It is sometimes also referred to as sub-millimeter wave or microwave spectrum. Compared to mmWave, centimeter wave has longer wavelengths and can travel farther distances, offering better coverage and propagation than mmWave spectrum, but has slightly lower data transfer rates. Like mmWave, centimeter wave technology is being used in the latest wireless communication technologies, including 5G networks. It is particularly well suited for providing coverage in urban and suburban areas, as well as indoor environments, due to its ability to penetrate obstacles such as walls and buildings. It can also support a wide range of wireless applications, such as autonomous vehicles, smart cities, and remote medical procedures. However, centimeter wave frequencies can still be affected by interference from other wireless devices and environmental factors, so proper network design and optimization are still required. Overall, centimeter wave is an important component of 5G networks, as it can provide wider coverage and support a range of innovative wireless applications. Generally, mmWave base stations require more antennas and smaller cell sites placed more closely together, while centimeter wave base stations may have fewer antennas and larger cell sites placed farther apart. The specific appearance of the towers can also vary depending on the manufacturer and the design of the base station. Both small cells and microcells are designed to work with high-frequency radio waves, such as mmWave and centimeter wave, to provide high-speed data transfer and low latency for 5G applications. Thank you for watching. Hope you enjoy my sharing. If you like my video, please like and subscribe.